My name is Jason Hall. I'm a solutions architect at Upsolver. And really the thing that I'm personally most excited about in terms of Iceberg is just the general ecosystem that has embraced it. I think it's a testament to the conference that we have today and all the different participants, but really kind of choosing an open format for data lakehouse architectures and the possibility that opens to all things data, right? Whether it's analytics, ML, any way that you might want to use it. So I was given the opportunity to demo how Upsolver can kind of fit into this open data ecosystem. Upsolver Ori introduced during his keynote this morning. Upsolver is a data ingestion platform, really focused at high scale data ingestion with a specific focus on real-time and streaming sources. So the use case that I'm going to walk through today is one of the most, I think, commonly understood streaming data sources, and that's security logs, specifically AWS VPC flow logs. We have a handful of customers working with these logs, and really the challenge is in taking large volumes of flow log data being generated in real time and then creating analytics-ready tables that can be used for a variety of purposes. So that's the use case I'm going to be walking you through today. So we're in the Upsolver platform. Again, Upsolver's got a few different primary capabilities, but what we're going to focus on today is data ingestion. And Upsolver offers a very simple approach to traditionally complex ingestions, again, specifically focusing on high-scale streaming data sources. Since this is a flow log use case, AWS makes it really easy to store flow logs in S3. As you'd imagine, we'll choose that as our source. And we're going to write that flow log data into our AWS Glue catalog. You'll see other options that we could write into, but we'll choose Glue for this use case. The wizard here allows us to connect to source and target, right? So 3 screens in the wizard, no code, really easy to step through. We connect to our data source. This is an S3 bucket that we make flow log data available in. If you want to try this for yourself, by the way, you can go over to the expedition station. This exact use case is something all of you can go through here at the conference. We also make the sample data bucket publicly available. So if you want to try it on your own after the conference, it's all available. You can work with the same data set that I'm working with today. So we're reading data from a bucket and specifically a flow log location that we're storing data in. We automatically infer the type of files. Flow logs are, I think by default, still stored in Parquet. There's a couple options, but we're going to infer that there are Parquet files that we can read from. So we've set up our source. We now set up our target. This is a Glue catalog that we've connected to. We're going to write into an Iceberg formatted table. We call this Upsolver Managed Iceberg, and I'll talk a little bit about what that is as we get more into the data. But we will choose a schema to write into. I'll write into this chill data schema, and I'll just call this raw flow logs. Okay. So we've set up our source. We've now set up our target. Last step is to set up the ingestion itself. I'm going to take all defaults here, but we can control how often we're updating the Iceberg table. The default is in near real time. We can control any sort of schema modification. The default is to ingest everything as it is in the source, as close to raw as we can. But you can redact fields, you can hash PII if you need to, you can set up expectations if you want to ensure you're not ingesting nulls or bad data into these tables. But for the purpose of this demo, I'll just take all defaults. These no-code wizards generate a few lines of configuration code that's going to create the table and set up the job. Uh-oh. Come on. This is actually directly connected. I don't even know how that happened. Sorry, my laptop is ahead of the screen. That is really weird. It's even moving my mouse, but I swear it's showing me something different on my screen. Showing up there. Well, can I force it? Wow, this is strange. All right, I'm going to click off and click on. This is there we go. All right, that's the click share version of a reboot, I guess. But so this is the configuration code. We're going to run this as is right through Upsolver, but you could run this through a CLI. You can run it through Python. We've got DBT integrations. You can kind of work with this code externally as much as you need to. But then we can go ahead and set up the job. So very simple to set up a relatively complex real-time data ingestion into an Iceberg table. I already have this running. So rather than make you sit and wait for some data to appear, I can go into the job monitoring UI. Upsolver provides a lot of observability into your ingestion jobs, which you can see here. It looks like somebody's at the expedition station right now that just created that one, so that's cool. But here's the job that I set up a few days ago. It's been, again, reading flow log data from S3, streaming that data in near real time into an Iceberg table that we're going to work with here in a little bit. But so we have monitoring built into the platform. And observability also, it goes kind of beyond monitoring and also into the data itself. If we go to this data sets dashboard, I can navigate into the table that I've been writing into. And you'll see everything from kind of trend graphs showing data, rows written over time. We give you schema statistics about the data that we're writing into the table. Again, the schema may evolve over time if AWS decides to change its log format, but we'll just pick up any new fields as they appear. We'll upcast data types if needed. And you can see statistics about that schema that we're writing in to the Iceberg table, including timestamps. This is really useful, especially for evolving data sources where the first time a new field shows up in a source or the last time an old field stops showing up in a source, you get the exact timestamp of when those schema modifications occurred. We also can look into table statistics, how many files are within our table, what's the size of each partition, how long does it take to scan the table and each partition, and all this metadata just comes natively as Upsolver ingests data into this Iceberg table. You'll see a tab here called compactions. So one of the things that Upsolver does automatically when writing into Iceberg tables is continuously compact data. And this just comes along with Upsolver, right? There's no need to manually compact. Just as we write data, we decide when we need to compact and we do it. And you can track the status of that in Upsolver. And these compactions are going to make querying this data much more efficient, much higher throughput. And you'll see a couple examples of that here in a bit. So that's the Upsolver side, right? And this is what Upsolver's been doing for a while now. You know, Upsolver is an ingestion platform. We write into Iceberg tables, and we make it really easy to ingest high-scale data into a data lake in this context. The openness, though, and why we're so excited about Iceberg, is it now allows kind of the broader ecosystem of vendors to connect into tables that Upsolver's ingesting data into. So I thought I'd show a couple examples. I'm probably not going to do these products justice, but I just wanted to show a couple examples about the ecosystem. This is an example of Starburst connecting to the Upsolver table that we are ingesting data into. And I've got two queries here. I actually ran the second one ahead of time because I didn't want to make you sit at an hourglass while it waits. But this is a query running against an uncompacted table. Right? So to show kind of the benefits of how we optimize and manage these Iceberg tables behind the scenes, and you can see the results here. So this query against an uncompacted table was processing roughly 38,000 rows per second. It took about 2 minutes to run. This table actually isn't even that large, right? But it's one of the challenges in working with streaming sources and uncompacted tables. If I turn around and run this one, again, pray. Perfect. All right, so it's running. You'll see we're not only going to be processing at a much higher throughput. Wow, that was pretty quick, right? So from 37,000 rows a second to 872,000 rows a second, and from 2 minutes down to 5 seconds, really just due to the fact that Upsolver's compacting continuously the files within this Iceberg table. Right? So here's Starburst connecting to an Upsolver table. Similarly, Dremio, another partner of ours, can connect to an Upsolver table. We can take the same query, run it against Upsolver, and again, do all of the things that Dremio is really good at doing, but against a table that Upsolver is writing into and optimizing through our continuous ingestion. You saw a demo from Snowflake, probably I think it was like 45 minutes ago. Here's a Snowflake example, right? Snowflake, through the use of external Iceberg tables, you can connect to a volume, that's an S3 bucket, that we are keeping this Iceberg data in. You can then create a catalog integration through Snowflake to connect to the Glue data catalog. And then you can create a table that connects to the Iceberg table in S3 and the AWS Glue catalog. And now, again, query Upsolver Iceberg tables through Snowflake. Right? So really exciting. We can kind of take this data even into data warehouses. And the last thing I want to highlight is what you've seen so far, kind of SQL queries running against Iceberg tables. But there are other types of queries that you can run. And for flow log activity, it might make sense to run something like a graph query, right? Because flow logs contain IP addresses and things connect to each other, and you might want to understand relationships, right, on how different IP addresses are connecting within a flow log infrastructure. We have a partner of ours, PuppyGraph, that actually allows you to run graph queries against Iceberg tables, right? Traditionally, if you wanted to run graph queries, you had to load the data and remodel it maybe into a graph-specific database. But I think it's pretty cool. And we can now run graph queries against Iceberg tables, maybe even the same tables that we're running SQL queries against, right? So here's an example of a graph query. It's looking at, I think it's the top 20 IP address connections by network packets. And if we run that in PuppyGraph, you'll see it returns the results. These are the top 20 IP addresses that are being connected to within our flow log data. And PuppyGraph wins the award for the best visualization. I think this is really cool. If you click on Visualize and click Start, so this is a graph of my VPC flow log data coming out of an Iceberg table, right? And if we zoom all the way out, you can see all the different connections. You can zoom in, kind of understand hotspots in your network, what's connecting to what, is there any external connections coming in? You can search for an IP address if you're concerned. So I think there's a really cool like security potential by maybe using graph queries against Iceberg tables that might be consisting of VPC flow log information, right? So that's what I wanted to show today from a demo purpose. Thank you, Verizon, for having strong 5G signal inside of a big building like this. I'll leave you with 2 QR codes if you want to learn more. And by the way, you are welcome to swing by the expedition station. Again, the exact demo I just went through is available if you want to walk yourself through it and get a feel for the process. If you want to try Upsolver for yourself, the QR code on the left will get you to our sign-up page. You can join our SaaS infrastructure, connect to your data, and process it any way that you want. If you'd like to learn more, maybe set up a demo or a conversation with myself or any of the other Upsolver resources, you can hit the QR code on the right. Just give us a name, phone number, email address. We'll reach out and would love to talk further. So hope this is an interesting demo. Thanks for the opportunity to share it with you, and have a good rest of the day.